Alright, here we have section 4.5, proving congruence by angle side angle and angle angle side. So, vocab and main ideas. Okay. So, just like you have what's called an included angle, which is the angle between two sides, you can also have an included side, which is the side between two angles, so it's kind of the reverse. So here you have postulate 4.3, which is angle side angle congruence. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So here you have angle T, the side between, and angle R. G pairs with T, side with side, C with R. So R, T, W. So they went double, single, none. So that's why this one is CGH. So example 1, two-column proof, given CP bisects BCR and also bisects BPR. So if that's true, if CP bisects BCR, that angle and that angle are equal. Same thing's true down here. That angle and that angle are equal. And then CP is congruent to itself, so we'll give it a double hash. So CP bisects BCR and BPR. Given. So if that is true, I can say that angle BCP is congruent to angle RCP. Definition of bisect. Same thing for the other side. Angle BPR, oops, not R, that's a C. BPC is congruent to angle RPC. Definition of the bisector. And then, so I have two angles, so I just need the side between them. So side CP is congruent to side CP. That is a reflexive property. And then finally, so I have two angles on the side between it. So triangle BCP congruent triangle RCP because of angle side angle. Got the paper all twisted. So there's your steps. So theorem 4.5 here is angle angle side. So it says if two angles and a non-included side of one triangle are congruent to the corresponding two angles on the side of a second triangle, two angles are congruent. So you have two angles and a side not in between them. So angle side angle, that's why it's written this way. The side is between the two angles that you know. Here, angle angle side, the side is not between the two that you know. Okay, example 2, two-column proof. So you know the angle EAD, so one arc there, is congruent to EBC, one arc there. And then AD is congruent to BC. So 1 is always your givens. Okay, so I have one angle, one side, so I need another angle of the triangle. So the only other angles in the triangle are angle D and angle C, but angle E is used twice, so I can use the reflexive property again. Angle E is congruent to angle E. That's a reflexive property. If that's true, I can say that triangle, we'll call it EAD, is congruent to triangle EBC. Keep your order right, by angle angle side. But that's not what it wants. It wants AE and BE congruent. Well, I just proved the triangle's congruent. Oops, yeah. So I can prove the parts. So AE is congruent to BE. So the reason for that, this is way back at the beginning, corresponding parts of congruent triangles are congruent. I think that might have been like postulate 4.1 or just a definition at the very, very beginning. So if you know two triangles congruent, you can say any parts of them are congruent by CP/CTC. Corresponding parts of congruent triangles are congruent. Alright, the last slide here is kind of just a summary of when you can use things. So definition of congruent triangles just says that all corresponding parts of one triangle are congruent to the corresponding parts of another triangle. So by side, 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 you have three sides of one triangle and three sides of the other. Side angle sides, two sides in the included angle, congruent to two sides in the included angle. Angle side angle, two angles in the included side, congruent, two angles in the included side, an angle side, two angles in a non-included side, congruent to two angles in a non-included side. So these are the four methods you can use to prove triangles congruent. Depending on the things that you know, that lets you pick which one of these you're going to use. If you know all three sides,